Good afternoon, everyone. Hope you're doing okay. Going straight on through, we have, yes, last week we did our post-processing, just kind of a real introduction with this idea that HyperWorks is going to start to have more post-processing, and you might think, well, why? Well, one of the biggest reasons why is going to be this free body workflow that I'm about to show you. So let's go ahead and bring in a model. I like my little airplane model. Just go import. Little airplane, okay. Yeah, I know there's a large field in there, that's fine. Okay, so this could be a bulk data file. I don't really care where this mesh came from. Let me quickly hide these RBE elements because they're the worst. Elements by config. Get rid of these bad mammer jammers. Okay. Hide. Okay, that looks more like a little airplane. Zoom, 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 zoom. The workflow that we have today kind of starts the same way as the results did. So in order to do free body diagrams, right, we need to have some results, right? Mostly grid point forces is what we need to request out. So I'm going to import in some results as well, much like I did last week when we did contours and all sorts of things. I have these 4 OP2 files. I'll just shift click and bring them in. These could be H3D, these could be XDB, these could be, pick your favorite result file type. We read them all. Okay, so not really concerned about contours, plots, any of this other stuff. We also talked about getting results out, so result query last week. Now we want to do the free body diagrams. Okay, so we skipped over this whole section, so it's but free body diagrams is what we're doing next. So we're going to learn how to do these, and that's what we're going to do. Okay, so kind of the prerequisites, you need a model and you need results. So I have a model and obviously I have these result files. Okay, so open up my free body tool. The load cases are going to be listed here, as you can see. I'm going to have some options down here, but I need to essentially make a free body section. Okay. The way that this will work is we will right click in this little blank space up here. I'm going to create these, but these can be imported from a file. There's going to be a few ways that we can go about making these, and I'm going to try to cover all that I can. So I made a free body section. Okay, big deal. I'll select it. This free body section is going to hold the important stuff for the free body cut, right? So, for my senior engineers, probably well versed in free body. For my newer engineers, let's take a quick refresher. The idea of a free body is to sum loads, a collection of loads over a swath of, let's call them elements. Okay, so I want to know kind of all of the loads from this, the wingtip to kind of this first, not first stage, some rib, right? Okay, so I would like all the loads summed up here. I'll say, okay, that's cool. And I want them resolved about a certain, node set or a node selection. And usually this the element selection and the node selection need, well, you can't see my hands, but I'm doing a very nice kind of Boolean, right? So these nodes are going to exist within the selection of the elements that I've picked. Okay. Where you want this resolved in, the centroid is usually the most common place, but you could also pick a certain point on your model that you would like these summed about. Okay. And I'll pick my subcase. Right now we can only do one load case at a time, but it would be hard to kind of put a bunch of free body diagrams, that's just, we'll get there. Resultant, fill out the information down here below. I'm going to go ahead and hit apply. Okay. And what I'm going to see down here is that I have some resultant force and moment summed about this point. There happens to be nothing in this. I guess that's probably like a local x-axis, and then y and z. So some kind of shear, and then some kind of out of plane load. I can pick a different load case, hit apply. Loads are different load case, hit apply. I have all sorts of options for how these look. So here's our fx, fy, and fz. Lots of different kind of switches and toggles that you can do to make this look as as beautiful as you'd like it to. And then we can also do just the boundary nodes, or we can also do, so this is the resultant force and moment. We could do a free body force and moment along that cut, if you would like to know what that cut, the forces at each of those nodes are along that cut. Could be done. Okay, so I would say this is pretty straightforward, right? If you want to turn the moments on, you can. That's perfectly fine. I'll just do back to resultant force and moment. So now again, you're probably saying, well, okay, why does this have to be in HyperWorks? What is the point? So the point is that 99.9% all of the time, we're using these free body cuts and loads in order to probably put them onto a refined mesh, right? So you have this global mesh, this big coarse mesh. You want to kind of sum loads about certain parts at certain areas, and then you're going to either map or remesh a certain part in order to do a more detailed analysis. Okay. But all of that meshing and detailed analysis, that all sounds like you need a preprocessor for it. So why not bring some of this post in, and we can do some of the pre. So the two buttons that I'd like to really direct your attention to, after you've kind of set up your free body force, is there's a load creation button, and also a field creation button. Okay, so fields, I believe we talked about a couple sessions ago. Field is agnostic to X, Y, and Z, right? So it's not node dependent, it's not ID dependent. This is going to say, well, there is a force that lives in an XYZ location, and then you have to define the rules for, say, well, I want you spread across these elements or these nodes, or et cetera, et cetera, et cetera. So we have two options here. Let's kind of explore what they do. So the first one is going to be load creation, and I am going to encourage you to look, I believe it's over here at this load collectors. So when I select this, it's going to say, all right, well, I'm going to put all your forces and moments. I'm going to actually make an include file for you. This is more of an organizational standpoint, but I think kind of a nice little feature. Click create. And what I see made is I see a new load collector. So instead of 83, there's now 84. And I see these grid point forces and moments at that cut plane that I've extracted. Okay. So kind of nice, right? These are the forces and moments. I didn't have to export them into a BDF and like re-import and overwrite other loads. This is just, it made a new load collector for me accordingly. And if I'd like, I can go and remesh some of these things, and these the loads will stay the same. Okay. So that's one option. So that's option A. Option B is maybe I'm, if I don't want to stay in this same meshed model, I'd like to get this out into a field, right? Like I said, XYZ data, et cetera, like that. So I can just hit create a field. And this says, what do you want? Forces and moments. I'll say sure. And then I now have two fields, one for my forces and one for my moments. Okay. Like this. Okay. And these reference tables. So these could just easily be exported. You can right click and export to CSV. So those are your two options. And so I think these are some clever options. If I showed the whole workflow, it would take a little while. I'll probably show this going from global FEM to local FEM probably in a subsequent series, and I'll probably do something like this. But there's another thing that I'd like to show with free bodies, right? So the free bodies are here. I just wanted to show you what happens if you try to pick multiple free bodies and apply it, since you can only do one at a time. So this is fine. There is a way where you can do all this, and you should be able to hit field, and this will make a field for each one of these. So I guess I should say the display of the free body force only works at one. I think I saw a question come in. So I think this might answer your question, is if you have I know you'll have thousands of load cases, but let's say you have 30 or 40 in particular, pick those 30 or 40, and we can generate the fields or the load collectors for all of them. We just can't display all of them at once, because that's kind of, I don't know how you would go about doing that. Okay, just wanted to point that out. Okay, so this is fine, but now you're saying, well, I need thousands of free body cuts, right? This is, you did this one, and it's just, you know, my plane is big. I have a lot of cut displays. I'm like, okay, well, fine. Hold on. I'd like to introduce you to a cross section. Okay, so a cross section is a little less node and ID dependent. So remember when I made this free body section, I selected a big swath of elements to sum over, and I selected a kind of the plane here. So I can make a cross section, and I can give it, you know, a kind of an initial location to start, and then I can give it a normal direction is really what it needs. Okay, so some type of normal direction this way. And I'll hit OK. And I'll hit close. So now I have a cross section entity. Let me show you this cross section. And instead of, when I go back to my free body forces now, instead of creating a free body force via nodes and elements, I do actually have a drop down for selecting a cross section. So I'll select this cross section from my list. Hit OK. Hit a load case, hit apply. And what this cross section does is it's essentially an infinite cross section, and it picks up the nearest nodes and elements that get intersected. Okay, so you don't necessarily have as much freedom as defining the elements that you'd like summed over and the nodes that you'd like, but you do get this fun little cross section, and you can flip which way which nodes on which side of the plane are getting selected. And again, I didn't do a great job of picking a good normal direction. But the other thing that you get with this, and we can argue how useful this is, and we're going to argue that it's not very useful, is this idea of having some type of slider is what I'm trying to say for this. Again, so it's kind of stuck on that plane, but you can kind of graphically slide this, and we can start to see, like, you know, here's the cut and summation here, and there's slide a little bit here. No. Again, as far as an engineer goes that likes to be very specific about things, this is pretty loosey-goosey. So again, there's not necessarily a tolerance on what this does. It just picks up the nearest nodes on one side of the elements that it's bisecting. And then again, you can flip it if you wanted the nodes on the other side. Okay, so this is fun, but also, I'm still not 100% sold. The last thing that I'd like to show you, we have these other ones here, they're good, is a trace plot. And a trace plot, I like to think of almost as, they could be free body. You could think of them as free body, but it's essentially defining X number of cuts on a given section, and then plotting, you know, like resultant force and moment. So this is maybe a little bit more of how do I plot multiple cuts at multiple places. Almost think of this as like a shear moment diagram inside of your model or on top of your model. I've had a few people talk about that. The same workflow, we'll select this trace plot. I don't really know why it's called trace plot, but maybe I'm just out of the loop. But I'll go ahead and hit create. And what I actually need to do is I need to make a particular number of cuts between, you know, essentially two places. So I want 10 cuts. I'm going to come to my other wing that I haven't, you know, demolished yet. I'm going to pick two nodes. So I'm going to pick essentially a node path, node 1 and node 2. Okay. I just picked this node path of this kind of more triangular part of my wing. And then the elements that intersect all of this are going to be about here. Okay, so 10 cuts. So I'm expecting to have essentially 10 cross sections running along the length of the swing. I'll hit create. And nothing particularly out of the ordinary gets done, except for the fact that instead of, you know, one cross section, this went ahead and made 11 because it needs an initial one, and 10 cuts needs 11 planes. So that's just how the math works. Okay. So I can say, well, that's great. I have this wonderful free body group. All of my options here for how I would like it summed and things. I'll take my load case and I'll hit apply. And what I see now is I see that I'm going to plot either fx or fy or fz or moments at each one of those cuts. Okay. These need to be scaled up a bit because my model is a bit larger, 1,000, and needs to be in the particular direction. Okay, so what I can see is that the Fx, my force in x, is increasing, right, as we go closer into the fuselage, which is kind of what you expect, right? There's very little resultant force and moment at the tip because it's being displaced, and all of that is just getting built up into strain energy towards here. So this is kind of a fun little tool. You can plot fx, fy, fz at particular spots. Once again, lots of different options for how this just looks. But it can be a super fun tool. This works on the fuselage. This works on all sorts of places if you'd like to see that kind of stuff. Okay. With that, I'm going to go ahead and stop today's recording and answer some questions. And yeah, I think that'll be good.